Good morning. My microphone fell today. This is gonna be scratchy for a second until I get it fixed. Okay. We are working on scatter plots. 10th of March. Define scatter plot. We've talked about strong positive, weak positive, strong negative, weak negative correlations, no correlations. And now we are trying to define each of these as positive, negative, or no correlation. First example, the size of a baby food jar and the number of baby food, and the amount of baby food a baby will eat. That's not real clear. And the amount of baby food a baby will eat. Is that a positive? Is that a negative? Or is that no correlation? Jenna?
Negative.
It's a negative correlation. I agree. Can you explain why?
Because as the size of the baby food grows, the baby won't be able to eat more of it, saying that it will probably be the same size.
Okay, so the size of a baby food jar and the amount, let's call this the amount. This is a bad sign to have here. And the amount of baby food a baby will eat. The size of a baby food jar. I'm sorry. This is really bad example. The number of, this might change your answer too, Jenna. And the number of jars, sorry guys, of baby food a baby will eat. Actually, it's not going to change your answer. It shouldn't change your answer, but it's going to make it more clear. So the size of a baby food jar and the number of jars a baby will eat. So as the size of the jar increases, what's going to happen to the number of jars a baby will eat? Everybody. It'll decrease. So as the size of the baby food jar increases, the baby's going to eat less number of jars, correct? So that was a bad example. I missed a couple words in there. So we have one data set increasing and the other one decreasing. So as the baby food jar increases, the number of jars will decrease. An example would be 1 jar, 2 jar, 3 jars. Let's call this 2 ounces, 4 ounces, 6 ounces. A 2-ounce jar, let's say the baby would eat 3. If we moved up to a 4-ounce jar, the baby would eat 2 or maybe 1.5. In a 6-ounce jar, the baby would eat even less, correct? So your negative correlation, you have your line of best fit. If you had a whole bunch of babies on there, you'd be good to go. So a negative correlation. B, the speed of a runner and the number of races she will win. Positive, negative, or none? Positive, negative, or none, Alex? Positive correlation. So as one data set increases and the other one's going to increase right along with it, and our definition of positive and negative says that both data sets are increasing. So the faster you are, the more races you're going to win. And the last one, the size of a person, the number of fingers he has. Positive, negative, or none? I mean,
none.
There's going to be no correlation here. When doing problems like these, I would probably ask you to provide evidence, much like I did here in letter A. So create a graph that explains your reasoning of why that's negative correlation. Understanding that negative correlation is one increases and the other decreases as far as your data sets. I would ask you to potentially write an example or show an example of positive correlation based upon the scenario. And then see even no correlation based upon the scenario. It'd be a little bit harder to create one of those. Key points here would be weak correlation and strong correlation, which isn't demonstrated in these examples. Positive and negative is a huge part of it. No correlation, line of best fit, and can you create a scatter plot? Questions on scatter plots. You guys good with these? Question?
A has of jar, jazz of. It says size of a baby food jar and the jars of.
And the number, of jars of baby food a baby will eat. That's what I was trying to do, but I skipped a few words. I was trying to go too fast. Does that make sense? I know I messed that one up, but hopefully it makes sense now.